All right, solving out some more integrals. Here we go. What we're going to do with these particular guys is find the antiderivative. In other words, what function can we take the derivative of that gives us the function we see behind the integral? The derivative of what gives me this thing. So if you've got some sort of cheat sheet or a trig card or derivative card or some quick math fact app or whatever, just scroll through there because some of these are a little bit tricky to see. The 5, though, is fairly easy. Derivative of what is 5? And remember, when you take the derivative, you use the exponent, multiply it by the coefficient in front of the variable, and subtract 1. So if there's no exponent, if there's no variable there, that means it has an exponent of 0. So this is like 5 times x to the 0, because anything to the 0 power is 1. So when I find the antiderivative, I need to add 1 to that exponent. So 0 plus 1 is 1. That means that the antiderivative of 5 is going to be 5x. Now, 1 minus x might look really 1 over x might look really difficult to determine the antiderivative of. But if you've got your cheat sheet, look at your list of derivatives. Derivative of certain functions equals certain things. The derivative of natural log x is equal to 1 over x. And if you aren't comfortable with that yet, stay tuned, because a lot of the derivatives that we deal with, or a lot of the integrals we deal with in second semester here, are going to work around the fact that we're working from a function whose antiderivative is going to be natural log of something, because we're going to have a lot of fractions. So 1 over x, the antiderivative of that is natural log of x. And then we're just going to evaluate this guy from 1/5 to 3. In other words, where you stop minus where you start. So 5 times 3 minus the natural log of 3 minus 5 times 1/5 minus the natural log of 1/5. And this is the same thing as natural log of 5 to the negative 1. 1/5 is the same as 5 to the negative 1. Think about what's going on there. And so then when I clean this up a little bit, I'm going to have 15 minus natural log 3 minus 1 plus natural log of 5 to the negative 1. Now, here's a really cool trick. Remember, when you're working with natural logs, you can take the number in the exponent and move him to the front of the natural log, or a regular log. So this would actually become 15 minus 1, 14, okay, minus natural log of 3, but minus natural log of 5. Okay, that negative 1 in front in the exponent comes out here to the front. Now, the other cool thing that you could do with this, and this is another reason why logarithms are kind of cool and nerdy, if I factor out a negative 1 here, another rule of logarithms is if you add the logarithms, you multiply the numbers on the inside. Well, the numbers on the inside are 3 and 5. So this would actually be 14 minus the natural log of 15. Now, this is the pretty answer that if you were taking a multiple choice test would be correct. If you're in my class, and we haven't talked a lot about logarithms and done a lot of stuff with those yet this year in this sort of way, I would be thrilled if you could get to this part. But these two answers right here are the same. This bottom guy would show up on some sort of standardized test. The top guy would be good for a question for me. Okay? Well, what about 9 sine x dx? Well, remember, some of our properties of integrals say that we can move any coefficient that's multiplying out into the front. So that really cleans up our integral quite a bit, because now we're actually working with 9 times the integral from 0 to pi over 2 of sine x. Derivative of what function is sine x? Okay, the derivative of what function is sine x? And in this case, that would be negative cosine x. okay? And we're going to evaluate that from 0 to pi over 2. And we're going to multiply the whole thing by 9. So when I put pi over 2 in for cosine x, I'm going to do where I stop minus where I start. So I'm going to have 9 times negative cosine pi over 2 minus negative cosine 0. So this works out. Cosine of pi over 2 is 0. So 9 times 0. And then negative pi over 2, negative times negative is positive. The cosine of 0 is 1. So I get 9 times 0 plus 1, or 9. Okay? Not too bad. Not too bad at all. All right, down here on the bottom, last guy. Derivative of what is secant tan? And we've got 9 secant x tan x. So again, just like our previous problem, this is actually 9 times the integral from negative pi over 4 to 3 pi over 4. And it's going to be 9 secant theta tan theta d theta. And theta is a variable, like x is a variable, so we can follow all the rules that we need to follow for derivative. And the derivative of what is secant theta tan theta? By the way, before I get too far carried away, this 9 is not there. So let's see here. Let me just move this guy over so it looks a little bit more cool. And I cut off the top of that theta. Wow, sorry about that. Okay, here we go. So derivative of what? Well, the derivative of secant is secant theta tan theta. So we would say that we're going to have 9 times secant theta evaluated from negative pi over 4 to 3 pi over 4. Okay? And when we do that, we're talking about where we stop minus where we start. And secant theta also might help to remember that this is 1 over cosine. All right, so if secant is 1 over cosine, the other way we could think about this problem is this way. Okay, and we just simply put in a 3 pi over 4 for theta. So what we're going to end up with is 9 times 1 over cosine of 3 pi over 4 minus 1 over cosine of negative pi over 4. And the cosine at pi over 4, all the pi over 4s is square root of 2 over 2. So what I'm going to have is 9 times 1 over, and 3 pi over 4 is in second quadrant, so cosine's negative. So this would be negative square root of 2 over 2 minus the cosine at negative pi over 4, and that's in the fourth quadrant, so it's going to be positive. So 1 over square root of 2 over 2. And remember that we're working with fractions here. And when you have a fraction, you can multiply by the reciprocal. Multiply by the reciprocal. So what we end up then with is 9 times negative 2 over root 2 minus 2 over root 2. Okay? Well, you may remember, and I'm starting to run out of room here, if you put these two together, that's going to be negative 4 over root 2 times 9. And negative 4 over root 2 times 9 is negative 36 over root 2. Okay? Now, that's a great answer. I don't have a problem with that answer. It's going to work. The only other way you might write this is if you rationalize the denominator. Okay? And if you rationalize the denominator, you're going to end up with negative 36 times 2 Whoops, times the square root of 2 over 2. All right. And when you simplify this guy, you would get negative 18 root 2. So these are the two answers you could get. This problem's a little bit more tricky because of the secant part. But again, solving it out, it's where you stop minus where you start, and that's how you put those pieces together. Use your trig card. If you don't remember what the cosine, what the secant is of 3 pi over 4, I'm sure you can find it. If you've got a chart handy, just look that up as well. But we can go for exact answers on this. This would be a question where a decimal answer wouldn't necessarily be correct. Most teachers would want to see that radical in the final answer.